Have you ever pondered the enigma of black holes? What are they and how do they form? Welcome to the captivating world of black holes, celestial bodies that have piqued the curiosity of scientists and stargazers alike. These mysterious entities are regions of space where gravity is so strong that nothing, not even light, can escape. Their presence is revealed not by what we can see, but by the impact they have on their surroundings. Black holes are intriguing, not just for their extreme nature, but also for the paradoxes they pose. They challenge our understanding of space, time, and the very fabric of reality. But how do these enigmatic entities come into existence? The answer to this question is intimately tied to the life and death of stars. Understanding how black holes form requires a journey back to the life cycle of a star. And that's exactly where we'll be heading in the next scene. Stay tuned. Stars, like our sun, are born in a cloud of gas and dust, known as a nebula. This isn't an overnight process, but a fascinating journey that unfolds over millions of years. Picture a vast, swirling mass of gas and dust, suspended in the infinite expanse of space. Over time, the force of gravity pulls this gas and dust together into a dense core. This is the birthplace of a star, and we call it a protostar. As the protostar continues to gather more and more material, it grows hotter and denser. When it becomes hot enough, a process called nuclear fusion begins. This is where hydrogen atoms come together to form helium, releasing an incredible amount of energy in the process. The energy pushes against gravity, creating a stable balance. Voila, a star is born. Stars live for millions to billions of years, but eventually they exhaust their nuclear fuel. When a star exhausts its nuclear fuel, it faces an inevitable demise. This end begins when the delicate balance between the inward pull of gravity and the outward push from fusion is disrupted. With its fuel depleted, the star can no longer maintain this equilibrium. Its core, now dense and heavy, begins to collapse under its own gravity. In a matter of seconds, the star's core shrinks dramatically, and the outer layers of the star fall inward. If the star is massive enough, this inward fall will trigger a dramatic explosion, a supernova. This event is so bright it can briefly outshine an entire galaxy. The supernova blasts the outer layers of the star into space, leaving behind only the collapsed core. This core is incredibly dense, with a gravity so strong that not even light can escape its pull. The aftermath of this cataclysmic explosion leads us to the birth of a black hole. In the wake of a supernova, a black hole emerges. This is the moment when the remnants of a star, once full of light and life, give way to a new form of cosmic wonder. The core that remains after the supernova is a dense, heavy mass. If this core has enough mass, it can collapse under its own gravity, forming a black hole. Imagine the gravity of the black hole as an insatiable cosmic beast, so intense that nothing, not even light, can escape its grasp. It's this immense gravitational pull that defines a black hole. As the core collapses, it gets denser and denser, creating a gravitational field that becomes increasingly stronger. This gravity pulls everything, including light, towards it, but nothing returns, hence the black in black hole. The black hole, a region in space where gravity is so strong that nothing, not even particles or electromagnetic radiation as light, can escape from it. And thus, a black hole, one of the universe's most mysterious entities, is born. So, the birth of a black hole is intrinsically linked to the life and death of a star. It all starts in a nebula, a vast cosmic nursery where clouds of gas and dust coalesce to form stars. These stars live out their lives, burning brightly for millions, even billions of years, but eventually, their fuel runs out. What happens next is nothing short of cosmic drama. The star's core collapses under its own gravity, triggering a supernova explosion. This is the death of a star, a spectacular event that lights up the universe. But it's not the end. Instead, it's the beginning of something even more mysterious. The core left behind by the supernova continues to collapse, shrinking down to a point of infinite density. This is a black hole, a region of space-time where gravity is so strong that nothing, not even light, can escape. Next time you gaze at the stars, remember, each one